Well, good afternoon. It's Comp 422 and Comp 620. We are talking about security policy models today. You'll find information on this in the textbook. What you should find the textbook, again, on Blackboard at the bottom of the blue menu on the left. There's a link to textbook, which was, by the way, on the blue menu, somewhere right below faculty information, there is a link for TA information. Mr. Ravel has put some information out there, and I'm going to prod he to do the same, to let you know that they're available. They also have the office hours on Zoom, Wednesdays, 3 to 4, which is kind of right before class. Okay, that's out there. Websites. The comp620.free.ns website was just giving me trouble all over the place. Everybody thought that was an evil, wicked, mean, and bad, and nasty system. It wasn't. I mean, isn't yet. I'm working on it. But all sorts of systems thought it was bad. I thought it was every web filter I had told me, nope, you can't go there. So I've changed it. I've gone to comp422.620.online. That hopefully you should be able to access. Somebody who wants to try getting there, let me know if you can or cannot get there, but it should be easily accessible. At least shouldn't get screaming error messages telling you that it's an evil site. During my testing, it seemed to work. So let me know if you have problems, but it should be easier to get to the old one. Right now, it has everything the old site had on it. The old site's still there for a while, so you can still get your stuff from there. Okay, so changing website. Kept me busy changing, but yeah, new one shouldn't cause trouble, I hope. All right. A little review from last time. We were talking about access and trying to determine who has what access. Noting that the system starts in an authorized state, and if it follows a set of steps that are authorized, then it should stay in an authorized state. You cannot give yourself any privileges. You can give privileges to other users, but you can't give them more privileges than you have. And sometimes you have groups. Microsoft or Windows, you can have groups of users, and then you have to worry about how to resolve multiple privileges. If you have privileges in different groups and a single individual belongs to different groups, then you have to merge those privileges. The merging means to give the user the highest priority permission that they are allowed in any group. If somebody does not have permission for an object, usually files, we're talking about files, but they don't have permission to access an object, then they can't access it. Unless they also belong to a group that does give them permission to access, then they can. But if you're denied access, that's different than not specifying. If the order hasn't said anything about whether you can or can't access it, then you can't. But if they said, no, you may not access it, then you can't. Here's the order. Remember that the highest priority is the deny, and then lowest is read. Oh, and write, well, even says write. Write means you can read, write, and execute it. Please read and write. Okay. Everybody understand this stuff from last time? Good. Then you won't have any problems when you come up with questions like this on the exams. Let's try this. Okay, we're going to hand here in class, we are going to hand out clicker cards, but we're going to should have a poll going right now online. So yes, keep your clicker card. Keep them for the rest of the semester. Please turn them in at the end of the semester, but keep them for the rest of the semester. Use them. If you lose them, let me know. Try not to lose them, or they cost money. But keep them and we'll use them throughout the semester, because I kind of keeps you awake. Lets me know how students are doing with this sort of stuff. Okay. Right now, we've got 40% of the online people. I'll fire up my app on my phone. Where did it go? Oh, how about right there? Okay, yes. That's right. The PowerPoints do not have the questions, and I took special care to remove all the questions from the PowerPoints. Okay, if that causes you a problem, because I put the PowerPoints, I don't want you to know that they're coming. And come on, wake up, wakey, wakey. Oh, I see what you're saying. Yeah, that's a. All right, here we are. Okay. Let me think about that. I understand your issue. All right. Okay. Put your answers up so my phone can see them. Oh yeah, they're coming in. Don't have. I can't read back there. All right. Okay. Oh here. That's right. Okay. How do we do? Oh, B is by far the favorite answer. And online, people like right. That is good because that is the correct answer. All right, they're out there. Almost everybody answered. The answer is B, right? Fred, again, is a member of two groups, the clandestine group and the weapons group. I won't wonder what that organization is, but the clandestine group has right, weapons group had read and execute. So you merge them together by taking the highest, right being the highest. So Fred has right access. Oops, you can see these. Oh, okay. And we'll put that to sleep. All right. Continuing on, remind you that we had access control matrix. When you look at these matrix, they're not implemented and completed because that be, the number of users times the number of objects like files. It's a very large matrix. So typically they'll keep either capabilities, which are the rows, what can this user do? Or more commonly, you'll see access control list. Who can access this object? And the advantage of having these groups is you can give the group access to this object, and then everybody who's a member of that group has access. You don't have to specify each user. You can just say the group, and that's it. All right. That was last Monday. Today we're talking about security policies. So we're going to look at the security policies, in particular, two important models for security policies, the Bell-LaPadula model and the Biba model. And so we'll talk about those and you understand those because they will appear in the next exam, I can promise you. Okay, policies. A policy defines what is secure for a system. What can you do and what you cannot do. And you can't say you are secure unless you have defined what it is to be secure. What do you want people to do? And again, it doesn't matter how wonderful your security system is if you don't have a good policy to direct it. So if you give everybody the keys, then it doesn't matter how good the encryption is. Okay, there are multiple types of security policies. You can break them down to 4 different groups. The government, military, has all sorts of policies. We were talking about their favorite policy shortly, which is the Bell-LaPadula. But there is a primarily for confidentiality, trying to keep you from seeing what they have. They don't want you to see the atomic bomb secrets. They're a little bit interested in integrity, but their primary interest is confidentiality. And then commercial systems is a little bit different. They're often more interested in integrity. Now, they are sometimes very interested in confidentiality. They don't want company secrets to get out, but they want to make sure internally that things don't get messed up. And then you can have particular policies that directly for confidentiality and don't talk to integrity. And then, of course, there's integrity policies that don't talk about confidentiality. The basic concept with these policies is if you start when you're in a safe state, when you're in a secure, consistently safe state, and you take a series of steps, transactions, your programs do things, the system takes these transactions, that moves you from state to state. And as long as you follow the correct transactions, the interactions go completely. These are what we call atomic transactions, in that you don't ever see half an action. Either it happens or it doesn't. You never see a mid-result. This is very common in database systems. They're built to have atomic transactions. Either you have updated the database or the database has not been updated. You'll either see the result of it all updated or the result of it never being updated. It doesn't let you see it half updated. And if you make these steps, the system will stay in a consistent, secure state. Okay. Trust is an important issue here because often we'll talk about integrity. Integrity is basically a trust issue. If you start with information that you can trust and then it follows a certain path, you should be able to continue to trust it. An example I have here talks about patches to the operating system. Can you trust putting these patches? Microsoft, on second Tuesday of the month, Microsoft likes to update the operating system and it wants to update everything. So you trust that the patch comes from the vendor and not from somebody in some weird country sending it to you. And then, of course, you trust that the vendor tested that patch. If you get an update for any product that you might have on your computer that you run, you hope that the vendor tested that. And, of course, you hope that when they tested it, that they tested it in an environment that sort of kind of looks like the environment that you're in. Because they tested an environment that doesn't look anything like yours, it might not necessarily work in your environment as well as it did in theirs. And of course, you're going to trust that the patch will install correctly. So you're making all these trust issues, starting with the vendor going down, because if it doesn't work, I mean, your system isn't going to work. Your system will sit there like a rock. Now, we can formally test these things. I mean, there's ways to formally check to see that the program will do what it's specified to do. Dr. Estline's big into this, but I'm not. Go see him if you want to. Basically, you can go and say, well, for each step, given these initial conditions, and this is the action of the step, this is the output that will be, and you make logical statements about that. So you can verify that certain things will happen, and you can verify security will remain secure or possibly not as it takes these steps. Unfortunately, formal systems are kind of difficult. Doing a proof of a formal system is not easy. I can tell you from experience, a bunch of students will mess it up. And there are automated theorem provers. You know, why do it yourself? There's programs to do it out there for you. That may or may not always work. They're pretty good, but they're not foolproof. They occasionally don't work. Also, if you're testing a system, you're testing it in some sort of environment. Is that your environment? Is that the environment in which you are using it? And then you have to worry when you're looking at the code of the program, is that really what's getting executed? Did the compiler correctly convert the code to an executable that does what the code says? The compilers are pretty good. They rarely make mistakes. What happens most, my experience, is the libraries. Yes, there's a library out there that your program is using that you never thought much about that doesn't work correctly. That's how a couple of years ago, there was something called the heartbeat problem. A library that many programs used turned out to be very insecure, and that it was a network product, allowed access to networks. So you use it through this network library, and then the network library has a flaw that if it attacker did something, they could look at all the program memory of your computer through that flaw. Well, everybody's system was suddenly very vulnerable, and not because their code was bad, but because they used a library that had a problem. And in fact, it turns out that updating libraries is a real challenge. Once you have the executable, somebody goes, what libraries are involved? Did I do that? I don't know. Who coded that? Did I use this library? It takes a while. You have to take a lot of good documentation to know all the systems that you are dependent upon. And then the hardware. The hardware is pretty darn good at executing what you say, but occasionally it doesn't work. I looked up Pentium F00F bug in Wikipedia. They refer to it as a halt and catch fire. It tends to make your system just stop. It's been fixed. It was an earlier version of the Intel processor, but when you execute it, it was not a regular instruction. It was a special instruction executed in a special way with a particular error in using it. In other words, it's not the way that you'd normally use it. If you improperly coded the instruction and you did something special, there's Intel has a lock feature where you can lock an instruction. For instance, if you have two cores and they're both out getting memory, you can lock something so one processor can get it and update it so the other processor can't. If you locked it and you did it wrong, well, it would stay locked. It would, you have to turn your computer off before it would do anything. So, yes. So there are policies, there are problems like that. So what it is that while you may trust it, there are always issues that things don't always work as you'd like. And while it usually will work, there is always the possibility that things don't work. All right. This slide, some of my slides I took from the textbook. Most of them are mine, but why should I waste my time writing a good slide when the author wrote a nice one? He had this policy question. I kind of liked it, so I kept it here. So think about this for a minute. And again, it's imagine university has a policy just like this about copying other students' homework. So look at this. So happens I have a clicker question for this. So think about it. I have those of you here, let's try it. It's A for Alice, B for Bob, C for both. Okay, I forgot to put the clicker question in the slides. Excuse me, I'm going to blame this Dr. Bishop for not putting the clicker question on the slide. It's his slide. What did you forget that? Silly him. Okay. So put your pictures over. Turn the wrong way. I gotta see it. Okay. Over there. Oh, what are we doing here? Oh, Bob is doomed. Hang him. Okay. Everybody dislikes Bob. Everybody thinks Bob is the evil one. So we'll. Okay. And yes, if you want to look at policies, that was we're talking about policy here. This is a security policy. The policy says that you can't copy another's assignment. And of course, in this instance, they are doing it. Everybody's using the same machines. You know, imagine 1 hour they're using it, the next class period, the next lab comes in, and Alice has her stuff on there. She put it on the computer. She didn't write protect it. And Bob comes in and goes, "Oh, look at that. There's the answer." So he turns it in as his. Who cheated? Is Bob? Is Alice? Well, I think it's pretty clear Bob cheated. Bob violated the policy. The policy says you can't copy homework. And Bob copied your homework. So Bob did it. Bob violated the policy. And this indicates that regardless of what the lab policies might be, university policy is you can't copy homework, and nothing the lab does is going to countermand the university policy. Alice didn't protect her homework. She should have. She didn't breach security because the policy does not say that Alice has to protect her homework. Now, Alice should take reasonable security. Alice should have protected her stuff from being read by other students. Policy probably ought to make some indication that people need to protect their stuff so that it doesn't make it easy for others to violate the rules. She didn't do it, but Bob was the one who broke the policy. There's example policies. Mechanisms. Policies and mechanisms are slightly different. They sound alike. A policy is a statement of what you can and cannot do. And the mechanism is what you use to enforce that they can or cannot do it. So you might say people cannot read this file. A mechanism is a system tool that prevents you from reading that file. So there's a difference between policy and mechanisms. Mechanisms come in two flavors. There are the technical ones, the ones that keep you from reading other users' data. We will talk all about them throughout the semester. Most of this semester, we're going to be talking about mechanisms, not policies. In fact, I think I'm going to burn through policies today, and you might not see them again for the rest of the semester. We're going to spend most of our time on mechanisms. How do you make these things happen? Or Or first, how do you keep things from happening? And we'll assume the policy is, we don't want that to happen. So that's policy. Procedural, again, is what you do to enforce that policy. What steps are taken for keeping somebody from doing it? And in this example, it's not so much a technical procedure. Procedural is you just fire the guy for violating the rules. And there are a lot of places when they say you can't do this, they are very firm about it. And if you do that, you're gone. If you work for the government, I know in a secure area, they say you don't take anything out of the facility. And if you copy some stuff you're working on, put it on a USB thumb drive, put it in your pocket and say, I'll work on it at home. No, you don't. Nope, that's a firing offense. Don't do that. All right, let's talk about some of these mechanisms. We talk about access control. We talk about access control a little bit Monday. Access control comes in two flavors: mandatory access control and discretionary access control. Like the name implies, mandatory access control is mandatory. You cannot get around it. Mandatory access control, users can't say, oh, you can access this file. No, there are certain rules, and the rules are always enforced. Discretionary access control is one that a user can say, you may access the file or you may not. They have the ability to provide you access at their discretion. Thinking of mandatory reminds me of that quiz we had. Let's just take a break here, maybe. Hang on there online. We will be back in just a moment. I can get this to work. Okay. Back to sharing the screen here. All right. Okay. What did I learn from the mandatory survey? I might point out that where it was mandatory, there were 2 or 3 students who just didn't get the word, and they didn't get 100. Everybody got 100 on it. They did not. Okay. All right. Class. Well, almost half of you are master's students working towards a master's degree. Bunch of seniors and some juniors there. You can see about a third of them are juniors and seniors. And then a bunch of 20%, or actually 19%, are students working on a certificate in cybersecurity. So that's how it breaks out. Not all the master's students are in computer science. In fact, there is a wide range of majors out there. Now we do have some bunch of computer science students, computer engineering, computer science engineering, computer applications, those sort of people. We also, and some bunch of cybersecurity folks out there, some electrical communication engineers. We do have a biologist. We do have a mathematician, a sociologist, African-American history. I thought that was unique, but fine. You're all welcome. Hopefully I'm not going to run away. It's been mentioned that there are a few things I mentioned that computer scientists may know that perhaps a biologist doesn't know. Like we used octal numbers, we converted the octal numbers to binary last time. I've got some stuff I'm going to put on my website that'll help you understand that. So just wait, that is coming. I'll put that up on my website this evening, and then you'll all become enlightened in how to count with just 2 fingers. Okay, so lots of people, so if you're out there with a business IT degree and you're wondering, what am I doing here? Don't worry, there's lots of people out there with different backgrounds. Now, how are you intending to attend? About 45% of you said you were going to do it secret. That's watching me online. Right now, there are 35 people out there in the ether watching this class. Another 20% intend to watch it sometimes later on. Again, I try to get these slides out, or excuse me, try to get the video out on YouTube so you can watch it. It does take a while. I mean, it takes at least a half an hour, 45 minutes of computer time. Just sitting there watching it slowly convert file formats. It does take a long time doing that. And usually close my laptop here, go home, convert the file, put it up to YouTube, and YouTube converts the file again. I have yet to figure out how to minimize the YouTube conversion, but it works. Okay, so you can see it. So again, if you're out there watching this video, so is about a fifth of the other class. So that's how we do it. Computers. What kind of computers do people have? Well, Windows is winning it, but Mac OS has got about a third of the competition. There is one person out there on Linux and one person out there on Chromebook. I hope it all works. So I'm going to make sure at least everything works in Windows and Mac OS. If you're a Linux user, well, you expect to have to work to make it work anyway. Chromebook, if you have problems, let me know. We'll see what we can do. By the way, my TA, one of the TAs are Mac users. So I usually throw my assignments at them, have them try it out on their Mac to make sure that everything works. So it looks like we've got about 95% of it tested by the time you get it. I could test it on Linux, I suppose. All right, programming languages. What programming languages do people know? Okay, there were 81 people in the quiz. A little bit more than 50 know Python. Python, C++, and Java are all very popular. Goes down SQL. SQL is a programming language. It's structured query language. It's used for database access. And we will be playing a little bit of SQL. Don't worry, I'll show you what minimum amount of SQL you need to do the stuff we're doing in this class. C#, PHP, and then none. Yes, number of students said none. Of course, a number of students also said they know multiple languages. The computer science undergraduates in general knew several of them, and they should. But yes, well, those are the ones that people know. So if I give examples, I'll try to stick to Python, C++, and Java if I have to. And again, this is not a programming class. You're not going to have to write programs. Although it is a computer class and computers run programs, and many of the security faults involve program faults. And we will spend at least one lecture period talking about programming techniques to minimize security faults. So that's the mandatory. You got any questions about the survey? Thank you for doing it. It does help me to know, well, where are people? What do you know? And that's first. Okay. So back to the lecture. I can find it. Okay. Please stand by. I got to switch from PowerPoint to Zoom and back again. There we are. Okay. Hopefully everybody can see the, by the way, just a reminder to you folks out there watching synchronously, which we know is most of you. I cannot see the chat most of the time when I'm sharing my screen. So if you have something to say, just turn on your, unmute yourself and yell at me. People yell at me all the time. I'm used to it. Okay. Well, again, we mentioned mandatory means you got to follow the rules. Discretionary means you can give other users access at your discretion. There's a version of Linux that is security enhanced Linux that enforces mandatory access control using the Bell-LaPadula model, which we'll cover in just a minute. It was created by the NSA for secure use, and security enhanced Linux they added this extra security model, and it denies access to anything unless you are explicitly allowed to access that. Android is based on Linux, and it is based on a security enhanced version of Linux. Now, in the Android world, you don't have multiple users using your phone. Each app, each program is considered a user. So using the basic Unix Linux is just a kind of implementation of Unix, using the basic Unix concept of different users of what they can and cannot access. Android uses that with what each app can access, each app cannot access. So there are files that a app may be able to access, or perhaps entities, software entities that an app can access, and those that they cannot. And it is enforced at the lowest level. Okay, let's talk about that Bell-LaPadula model, because it's a very important one in security. It's been out there since 1973 when these two guys, of course, Bell and LaPadula, made it. It is a mandatory access control model. It is probably the classic mandatory access control. It's the basis for a lot of security systems, so it's very useful to use. The government uses it. Okay, let's talk about that. So in the Bell-LaPadula model, there are security levels. Now, we're going to talk about the government's implementation of Bell-LaPadula, which has 4 levels. Top secret, which is obviously the highest level, secret, confidential, and then unclassified, where unclassified is the lowest level. You could have more levels. If you wanted to use this as a model, you can implement it any way you want to. You could have 5, 6, 8 models, whatever many levels you find important. But in the Bell-LaPadula model, as it's used in the government, there are 4 models. Or, excuse me, 1 model, 4 levels. And it's obvious what they are. Both people and objects have security levels. So an object, a file, a software entity, access to the printer, access to the camera, all those are objects and they have security levels. So people have security clearance. Many students in computer security here at A&T go off and work for the government in the area of computer security. To do so, they often have to get security clearances. I used to have these old FBI guys, excuse me, well, yes, they were retired FBI agents who are moonlighting as security clearance people. And they come and they ask me questions about students, ex-students, alumni. What do you know about Fred? Does Fred do this? Does Fred do that? Does Fred belong to an organization that advocates the overthrow of the government? That used to be a silly question. But look at the news these days. I see organizations that advocate the overthrow of the government by force. Well, anyway, they're out there and checking it. Security clearance, you see, the top secret clearance takes about 6 months to get because they go out and they check everything. They ask all about you. They ask about your family. I remember one student who was quite upset that he would not be allowed to have top secret clearance because he had an uncle who wasn't a citizen. And part of it is your relatives have to be citizens. And he was going, but I am an honest American citizen. He'd been a Marine. He was an honest. And they weren't going to give him a top secret clearance. He was not a happy camper. Okay, so they checked very carefully. Excuse me. Okay, now in the Bell-LaPadula model, we talk about reading down and writing up. Information flows up, not down. So you can read down. You can read things at a lower level, but you cannot read things at a higher level. So if you're at level secret, you may not read things at top secret, but you can read things at confidential. So we're going to use some set notation here. We'll have several statements like this. So an object, so subject S, that's human, usually, can read an object if and only if, the IFF means if and only if, the level of the object is less than or equal level of the subject. And then usually they have this discretionary thing. If S has permission to read, that's just if the levels are all the same, but somewhere in the discretionary system, somebody said, nah, I don't want you to read it. They give me deny. That overrides it. So we have mandatory access control and discretionary access control going on at the same time. And so since I got some of this from the textbook, I'm copying their statements. They have the mandatory part here and the discretionary. The mandatory part says you can look at the object if and only if that object's level is lower or equal to your level. You cannot look at something higher. No reads up. Okay. In addition to writing, you may not write down. If you are a top secret person, you cannot write information that is at the confidential level because you know secret stuff. if you wrote something, it might contain secret information. If you put it at the confidential level, you will leak information. And therefore, people at the confidential level will be able to see things that was top secret, and that's just not allowed. The Bell-LaPadula model, if you start in a consistent state and you follow these steps, then you will stay in a consistent secure state. But we have the star property here. We'll get to that more, but basically, this is the rule. The subject, human, wants to write to an object if and only if the level of that object is greater or equal to their level, and then the discretionary part. So it's no writes down. You can write up, but you can't write down. Now, some people think, well, isn't this kind of silly? That you, if you're a secret, you could write something that's top secret. Well, that's possible. It is possible sometimes to merge information at one level and come up with a result that you might feel is more secret than what it was. You hope somebody else doesn't do that. You make that more secret. Think of big data. In the world of big data, some of you may be working in big data. We have a lot of faculty doing that. You look at lots and lots of information and you find patterns in there. And it might find patterns that tell you things that they wish was more secret than what you found. So they make the result of what you found secret, top secret, or at a higher level than what you did. So it's possible to create information, and then you will write it. You can write a report that is at a higher level than the information that you were looking at. Let's give some examples here. Okay, we've got the four levels and the priorities: top secret, secret, confidential, and unclassified. Put some people at those levels, and maybe many people at those levels. I just put one for examples. And then there's some objects. And of course, there'll be many objects at each level, but I have examples. Okay. Tanya can read all these. Tanya can read all the files. She can read the personnel. She can read the phone list because she's top secret and she can read down. Claire here is at the confidential level. Claire can read the activity logs. She can read the phone list, but Claire cannot read the email files or the personnel files. Those are at the higher levels. She cannot read high. Umoja, he's down here at the unclassified. He can look at the telephone list, but he can't read anything else. Likewise, of course, Tanya can only write things at the top secret level. She cannot write something labeled at any lower level. And Umoja could write things at any level he wants to. If he ever dreamed up something that was top secret, couldn't read it. Yes, you might note, it is possible for someone to write something and then not be able to read it. We'll cover that in just a few minutes. Okay, so the basic concept is that if you start in a secure state and you follow these steps, you follow these rules of the Bell-LaPadula model, in the star property where each one, then it will remain in a secure state. Okay, does everybody understand how to apply the rules? Okay. All right. Let's give some examples here. Let's try this one. Take a look at this. I just so happen to have a poll for that. Okay, hopefully online you can see that. Yes, it says a poll has been launched. Right? Fortunately, there are only 4 levels and you only have 4 sides of the cards, so it's going to work.
I can't see the poll online.
Excuse me?
I cannot see the poll
You cannot
online.
see the poll.
No.
Me
Oh.
either.
Okay, hang on, let's try that again. It says a poll has been launched. Oh, hang on here. Let's all right. How about that?
We see it now.
You're on. Okay. Sorry.
Thank
It
you.
was so much fun. Oh, there it goes. Well, I recognize me. I'm here. Oh, okay. Yeah, saw it. That's your opinion. Good deal. We're on. Okay. Yes. Some of the online people catch up. Some people are falling asleep and they got to wake up now. I know it's tough. By the way, if you're watching this as a recording, do think about these. Don't just zoom ahead. All right, that's enough of this. Most people said top secret, which is correct, because there are material at multiple levels. If Elliot is going to look at material at multiple levels, read material, then he must have top secret clearance. All right. Do that. Go away. Okay, there we are. All right. Now, let's expand this model and make it a bit more complicated. In addition to security levels, there are categories. One might have top secret clearance for nuclear weapons, but you don't have top secret clearance for who are the spies wandering through that country. They're different things. So you might have top secret clearance for one thing, but not another. So in addition to having the proper level, you have to have clearance for that category. So security level is a combination, security level is what level you're on and what category you have. Now you can be in multiple categories. Let's look at some examples here. This person or object, both people and objects have categories and levels. This person is top secret and declared for nuclear Asia, or I guess nuclear Europe and Asia. I borrowed this slide from the author of the textbook. Somebody confidential, Europe and Asia, and somebody secret, nukes in Asia. Okay, so that's it. Now, there is this dominating relationship that specifies relationship between one object and another person. This is important. This is what all this Bell-LaPadula model rests on this. So let's look carefully at this. And what it means is that, say we have A and B. Well, A, in this case, let's say A is a human, B is an object. You can also look at it the other way around. If A is an object and B is a, but we'll say A is a human, B is an object. If we have human with the level and a category, and again, that could be a set of categories, dominates an object with a level and a set of categories, if and only if the human's level is greater than or equal to the level of the object, and the categories of the object are a subset of the categories of the human. Got that? Let's look at some examples here. Okay. And again, it also works with humans and objects, or objects and humans, two things. Okay. If something is if a human is top secret and they have the categories nuke and Asia, they will dominate something that's secret and nuke. It's because top secret level is greater than secret, and nuke is a subset of nuke and Asia. Secret dominates, secret nuke Europe dominates because secret is greater than confidential. And in this case, nuke in Europe is exactly the same as nuke in Europe over here. So they are a subset. They don't have to be a proper subset. They're equal class. That's okay. Yes, the little symbol there is subset or equal group. Okay, here's some that don't work. Top secret does not dominate confidential Europe because even though the level of top secret is greater than the level of confidential, this is not a subset of this. This is Europe. That's not a subset, so it doesn't dominate. Good enough? Confidential Europe does not dominate top secret nuke because this is a higher level than that. And top secret Europe does not dominate secret Europe because even though top secret is a higher level than secret, Europe and Europe, they're both Europe. This is nuke Europe is not a subset of this. Even though they're both Europe, this is not a subset. So therefore, it doesn't dominate. Yes, you have a question. The second one? Oh, okay. This does work because the levels, secret is a higher level than confidential. And the subset here, this is nuclear in Europe. I assume that's what nuclear in Europe. And the object has both the same category as nuclear and Europe. And so as long as there's basically, as long as there is not a category in the object that isn't in the category of the user, then we're okay. But if there's a category in the object, then you can't look at it because it's got a category that you're not allowed to look at. Does that make sense? Did I sort of answer the question? Okay, we can try again. All right. And this little relationship is what explains it all. Okay, moving on. Levels. Security levels are kind of partially ordered. Back up for a second. I might mention for you, we're defining sets here, and if you're into sets, I know there's at least one mathematician out there. This is not a symmetric relationship or an asymmetric relationship. Okay. Again, when you talk about security levels, you have to look at the dominates. The dominates is what we're going to use. Dominates because it uses both the clearance categories and the levels. And so we're going to order in this. All right. So still have the rule that you cannot read up. You can only read at your level or read down. And you have to dominate them. In other words, person can read an object if and only if they dominate the object, which means that their level is equal to or greater than the object, and that the object's categories is a subset of the subject's categories. Okay. And again, it's based on that dominate relationship. Writing, very similar. You can write up, you can write to the same level and the same categories, but you cannot write to high up. And you must, in this case, let's look at it. The subject can write to an object if and only if the object dominates the subject. Notice it's backwards. In order to read it, the user had to dominate the object. But in order to write it, the object has to dominate the user, assuming that the subject is a human and could be a process or something. Okay. If you send messages, if I am going to send you a message, then my message will be at my level. And my message will be, if I have secret Europe, then I send a message to you, it will be at the secret Europe level. Well, unless I can specify it's a higher, I could write it as a higher level, but I can't write it as a lower. Okay. So again, if you start in a secure level and you follow these dominate rules and go through all the star property, then everything will remain in a secure system. That's the big thing about Bell-LaPadula. You can prove that if you start secure and you follow all the rules, information will not leak out. There's no way that somebody can see top secret information unless they're top secret if you follow the rules. Okay, I have a whole series of clicker questions here, so get ready. Here they are. Okay. All right. Get your cards up. I have to see the cards because you're looking at this and count. Here. Oh, yes. Keep your card. You don't have a card with a pile of cards here. Oh, oops. One second. What happened there? We have having phone issues. Okay, well, that's not the answer. We have a mix. People like both. No, the answer is not both. The answer is D, none. Some of you got that. The answer, no, Paul cannot access the document because even though it's basically Paul does not dominate that object. And the object does not dominate Paul. Yes, Paul has top secret is greater than secret. So we got that. But BC is not a subset of AC. There's a B in there. So Paul cannot read that because there's B-type information in there. Paul's not allowed to read B-type information. Likewise, you can't write it because it doesn't dominate the other way, because it's at a lower level. So there's no access. People understand that. There's no, can't get there from here. So Paul is prohibited from reading, writing the object because wrong level, wrong categories. Okay. Let's go to the next one then. Try this. All right, well, let's. Oh. Oh, okay, we're on. We got it. We're up. Hey. Yeah, gotcha. By the way, keep these. I do not keep track of how you answered. I don't do any graded material during the lecture. This is just to make this so you can see and I can see how you're doing. As you can see from the last one, we weren't doing too well, but we're getting better. I can tell you because I can look at the answer here and I can see that most of you, a little bit over half, answered correctly. The answer is none. Okay. Mary is confidential C. The document's confidential. So the levels match. The levels are okay, but this area B and Mary C. So this is not a subset of C. So no access. You cannot read it because yes.
So what makes it a subset? Is it it's both the same?
If all the letters are the same, or is a subset if there are no letters in the object that are not in the user. So in this case, yes, if this had been C, it'd be okay, but in this case, we'll look at some other examples. Let's go to some of the other examples, and then we'll talk about, keep that, don't lose that question. Okay, let's go. We do this one? Yes, all right, we share these, stop, you can see it, very good. Stop doing that. And then the next one. Okay, try this. No worries, only a couple more questions. Oh. Oh, what? What's going on here? Oh, you go. There we are, okay. Okay, that's, sorry for technical difficulties. Don't you like computers? They don't always do what you want to do when you want to do it. Okay, listen, we picked up everybody. Okay. Yes. Well, in this case, the online folks are on it, but I'm afraid those folks out there in the ether are not doing as well. Okay. Fred has got secret and Fred is secret and C, this is confidential. Fred can read the document. The answer is A, read. Because, you can see how I did. Because Fred dominates the object. The object is Fred is at secret, the level is greater than confidential, and the category here, C, is a subset of this Fred's category. In fact, they're the same. So in that case, they dominate. Well, Fred dominates it. They can't do both because the object doesn't dominate this. You can't. So, okay. All right. Agree with that? Yes. Can't write the object because you can only write up. And in this case, Fred's at secret. That would be writing the confidential, and you can't do that. It's writing down. Okay. All right. Spent all my time writing these. Oh, wait, back. Okay. We're on again. We're going through a lot of these because I can promise you, questions like this will appear in the next exam. I like these questions. They're so easy to ask. They have a definitive answer. They're multiple choice. The computer will grade them for me. I love it. Okay, so, and the Bell-LaPadula model is a basis for many security models. This is what the government uses. It's important to know. Okay. All right, let's see. Okay, hey, majority have it right. The answer is A, read. Susan can read this. Susan has top secret AC. Document is confidential. Secret is greater than confidential, so it dominates. So dominate again requires that the level is greater and that the set of categories of the object are a subset. So the category here is A, and Susan is A and C. There's an extra one there, but it just requires a subset. So this is A. Okay, so, all right, do not worry. One more. Oh, question? Excuse me? You can, no, yes, you can write up, only write up or at your same level. You can write at your same level or up, but you cannot write down. You can't, you can read it, but you can't write it. Okay. All right.
Dr. Williams, the poll is up, but we can't see the slide for the question.
Oh, gee, picky. How about that question? Some people
Thank
already
you.
answered the question too. They were said, by the way, poll people, you can change your mind. You know, it allows you to change your mind. Okay, this you'd be happy to know is the last question for this stuff. Okay. All right. Cards up there. Good. Stop changing that. Big guess. All right. Okay, I think everybody. Whoa, I hope that's the right answer. Yes. Okay. Hey, we're catching on to this. The answer is D, none. There's no clearance. Plus, you're in classified, you don't have any categories. You're just, you know, like me or you. I don't know if you have a security clearance. I don't. I worked in an area of security, but nobody wants to give me a clearance. It costs a lot of money. I think it costs like $60,000 to give somebody a security clearance. So when an agency wants to hire you and wants to, before they hire you, they have to do a security clearance on you. It costs money, about $60,000. So it's an expense that the agency is going to make. Of course, they're the federal government. Who's got more money? But okay, the answer here is none, because this is, you can't read up. There's a category, you can't write it. Can't write it because categories don't match. Okay, pretty good with that. We're done with that. And we'll move on. No more of those category problems. Okay, now, here's an interesting problem. We have two humans. And again, they're sending messages. So when they send messages, they send messages at their levels. Now, we have two humans because they might want to send messages back and forth. They have the colonel and the major. Okay, colonels, they're both secret. They're both secret. The colonel has nuclear in Europe, and the major has Europe. So the colonel can read a message from the major. Because the major sends a message to the colonel that's at secret Europe, and the colonel dominates that. If the level is equal, and Europe is a subset of nuclear Europe. So the colonel can read those messages. But they can't write messages that way because right, no higher than that. So we have a problem that one person can talk to one person. They can't talk back and forth, which is kind of silly. Yeah, so how to fix that? Okay. You have, by default, what we consider the maximum and the current maximum security levels and the current levels. And you can allow them to temporarily step down for a particular level. So treat the major as an object. The colonel's trying to write him or her. And then they have the maximum step down to a current level where they skip the nuclear stuff. And once you drop out the nuclear, then everything, then they're both Europe, they're both subset of each other. It works just fine. The problem is that the colonel knows this nuclear stuff, the major does not. But the colonel is a human, and we're trusting that the colonel will be smart enough to not tell somebody about secret things that they don't have clearance to know. Okay. So there's the concept of tranquility, that things do not change security level. As a general rule, you have an object and it stays at its level, it stays at its category. Those things don't go randomly changing. Once you set it there, that stays that way, it will not change. That makes it easy because then things don't go changing and the rules follow. The star principle allows you to move from state to state and we end up in a secure state. We have strong tranquility, which is what you'd expect it to be, that things don't change. Once you set it that way, as long as that system remains, as long as that object exists, it has those categories. Weak tranquility allows you to make those changes like we did with the major and the colonel, that they can make current levels and the maximum level. Declassifying objects presents an issue. If you want to declassify something, then you are violating the tranquility rule. If an object is at top secret level and you're going to move it down to secret, you're changing its classification. Or more so, if an object is secret or even confidential and you can move it down to unclassified, then you've changed it and you have to make sure that you aren't releasing secrets. The government does this all the time. The government's constantly declassifying stuff, although they classify stuff at a very high rate anyway, so they have to scurry very quickly to declassify stuff so they don't overwhelm themselves, which they actually do. Before they can let it go, they have to sanitize it. Human beings, read through it, make sure there's nothing in there that they're releasing that shouldn't be released. They say we're going to allow everybody to see this information about UFOs. But if they're going to do that, they don't want to make sure they release anything about nuclear weapons or rockets or missiles, whatever else. So they're going to declassify things. They have to sanitize it. And it's a long and tedious process involving multiple humans reading it. That is in the news, if you've been paying attention. Former President Trump had a bunch of boxes, and so did Joe Biden, and so did Mike Pence. It's a common thing, I guess. I do not have a box of secret material in my garage. I don't know what these people have a problem. But they had secret documents, top secret documents, and now they are indicting the former president and maybe the other guys on this and trying to penalize them for having these documents when they are not supposed to. I might note that Mr. Trump claims to have declassified the documents, although the declassification process, as I mentioned, is lengthy and reviewed by multiple people, and you just can't wave your hands and say it's declassified. Okay, so that was, talk quickly. That was trying to keep information secure, confidentiality. There's also the question of integrity. Integrity makes sure things are trusted. But integrity and trust is very closely related. Let's look at, and there is a model for this. Integrity goals is you want to make sure that people don't modify things that they're not unauthorized to do. You don't really care in this case if people see the information. You care that they cannot change information that they shouldn't be allowed to change. So you want to make sure it maintains a consistency. There is a model for this. This is the Biba Integrity model made by Ken Biba way back in '75, a while ago. So yeah, that's ancient history for you. I was there. So the model says you're not going to corrupt the data if you follow the rules. It's going to remain integrity. Just like the Bell-LaPadula model, there are levels, not necessarily categories. We can talk about categories, but levels. And we're talking about trust here. So it's the inverse of the Bell-LaPadula model. With the Biba Integrity model, you can not read down, you can only read up. Of course, you can always read at your own level. And you can write down, but you can't write up. So it's the inverse of that. There's a nice example that I got from someplace that I love this. Okay. We've got this. You can create content, you can write at your level or a lower level. So we've got a monk can write a prayer book that can be read by commoners, but it cannot be read at a high priest. Assuming the high priest at a high level, the commoners at a low level, and the monks at level 2, the monk can write down level, write for the commoners. He cannot write something to be read by the high priest. Meanwhile, the monk can read a book read by the high priest, but cannot read a book read by the commoners. Trying to keep things, presuming the high priest know whatever high priests know, or high priestesses, and not keeping things trusted, that they can look at the trusted information from the high priest, but they can't look at the stuff from the commoners. Okay. And another example in the real world here, imagine you have software updates. You have a level of trust. And again, the integrity model and trust are very similar. Is it integritous? Can it be trusted? Can you make sure that it came from them? Imagine you've got 3 levels. You have vendors, people who made software who are now providing patches. You have some IT administrator who oversees an organization and makes decisions of what patches are going to be applied. And then you have lab managers, multiple lab managers, and they decide, and they install the patches. Okay. We're applying the Biba Integrity model. So the IT manager has to trust that the patches come from the vendor. The lab managers are told by the IT administrators to trust the IT administrator. But you don't get patches over. The lab managers cannot send information, cannot send patches to the vendor. So, yeah, let's try this one last question. We have just a few more minutes, so we'll try this question. Again, we have my example with the high priest, the commoners, and the monks. I just don't look like them. Okay. Last question. Oh, okay. I put up there. Okay. Important. My phone has to see it. Fuzzy today. How does it like it today? Oh, that's it. Okay. There we are. All right. Yeah, good. Okay, what axis is it? And the poll here, share the results. What axis does it have? Well, the commoner can read prayer books from the high priest, but they cannot, of course, write something that the high priest or the monk will look at. Again, you can read up, you cannot write down. Okay. Write down, it's exact inverse of that. Just about, oh, we still have 5 minutes. Okay, categories. Biba doesn't really have categories. Might you have categories? You could probably think of a way to put categories in there such that make sure that you don't write into areas that categories you don't know about, where you would not have the knowledge. You would then corrupt the information. There are also availability. So we have, remember the CIA letters, confidentiality, integrity, and availability. There are availability policies. This is in chapter 7 of the textbook. It's 1 page. It's not much about availability policies. So basically, the availability says, make sure people can access it, that they can access it within a finite wait time. And I say finite wait time, and there's no always definition. Sometimes they define what finite is within a certain amount of time, but it's not infinite. Because you will not get into an infinite wait. All right, that's it for today. A couple reminders. Labor Day is coming up on Monday. There are no class on Monday. Don't come here. I won't be here. Don't go out looking on YouTube because it's not going to be there. No class on Monday. All right. New website. You should. Oh, why don't I say you should? Hang on for a minute. Don't go away. We're going to test this. Note, I changed the site. It's Comp 422, Comp 620.online. I got this for your undergrads. I got you involved. This just wasn't working. And there are the textbook. No, by the way, there's not a lot of reading. Sections 1, and 2, 7, 1. There's not a lot. There's only a few pages. Read chapter 10 for next week. And just let's go out. Okay, hang on, folks. We are going to go out to the website in just a minute. If I can get this to work. Okay, how do I make this small? How do I? Okay, well,